Hi everybody. So we thought we would do our physics project on projectile motion. A projectile is anything that falls through space acted upon only by gravitation of the Earth. It could be like a ball falling or someone throwing a ball or something. In this case it's going to be a motorcycle jumping a jump. So Zach is going to be explaining what is going to be happening in our physics project today.
So in our project we're going to have the stuntman come at a jump with a velocity v, and after he gets to the top of the jump he's going to go at a parabola at a certain distance, and we're going to use, and he'll also be going at a certain height, and using the time that he's in the air for and the distance that he travels we'll be able to find the velocity that he's going. Once our stuntman leaves the jump, the velocity that he's going will be broken up into two parts, the horizontal velocity and the vertical velocity. To find the final velocity, we'll do the equation v equals the square root of vx squared plus vy squared.
So now you guys are going to see the actual tests that we did when Jonathan jumped the jump. Now right when Jonathan leaves the lip of the jump, a timer will start, so you'll see exactly how long he was in the air for. Okay, as you can see, the time that Jonathan was in the air is 0.701 seconds. So, if you were to put that into the equation for velocity horizontal, which is Vx equals d over t, distance over time, then it would look something like this. Now, we were able to measure Jonathan's distance that he jumped, and it came up to about 13 feet, which, if you translate that into meters, would be about 3.96 meters. So then you're able to substitute 3.96 meters in for the distance in your horizontal velocity equation, and that looks like this. And then once you solve it, it comes out to 5.649 meters per second. So now you've found your x component of velocity, or the horizontal component, but according to your velocity equation you have to find the y component of velocity, which is the vertical side. So you find that by using the equation for velocity y, which is force of gravity times the time it takes to fall, which is half the time that he was actually in the air. So the entire time divided by 2. Once you've divided the time by 2, then you can plug it into the equation along with the force of gravity, which in this case we're using 10. So you just do 10 times half the entire time. Then you plug both the velocity x and velocity y into the equation and you get 6.648 meters per second for the total velocity. Now that was our slowest trial. We have 2 more trials, and we're not going to walk you through them, but watch and see how the velocity change, because it's going to increase. Watch and see how that affects the distance and the time that he's in the air for. It'll show you how fast he's going for each one.
Trial 2. Trial 3.
Okay, so that concludes our video. Here's a nice graph.
So that concludes our video. Here's a nice graph that, your teeth are looking me. Your teeth, dude, they're just smiling at me. That concludes our project. Here is a graph that shows what you guys already know. Everybody already knows this. The faster you go off a ramp, the the further